Okay, so this is a demo of the grid layout test object, and what we want to talk about here so what we're looking at. So we have two visual references. This is a swatch at 50/50, which is actually the original parameters of that prefab object. So we have a prefab object called swatch 50/50. This is its size visually on the canvas. Then we have a that is 100 by 100. This is just a visual cue just off to the side. So these two here are visual, not part of the test. There's a panel object right here, which is 500 by 400. I have it just centered and anchored to the center. Nothing special going on there. Pivots in the center. And then I have a grid object. So this is just a game object. Right now, its width and height are 500 and 400, which are the same size as the panel object. Just for visual, we'll explore how that changes things here in a minute. But this is the grid layout group. All right, so I'm going to change the child alignment here to middle center, fixed column count of 3, and then we'll run this program. Okay, so we have a grid of 6 elements here. We have these swatch clones, which were instantiated in script. I'll show you how that works here in just a second. And we have, so this thing here in the middle. Now, there's a child alignment property down here that we can change that will move the grid system around. It is kind of interesting to note that these guys do break the top of the panel, but I think that's actually because the panel itself has space around it. That's interesting. If we go none, yeah, so if I switch it to none, you can see it lines up all the way to the top. There we go. Okay, interesting. Okay, cool. All right, so back to the grid. All right, now these objects here notice that they are completely grayed out. This is because some values are driven by the grid layout group. The grid layout group locks the elements in the grid to the size of the cell size of the grid. So if I were to change the grid cell size to 50/50, they would be 50/50. All right, but because it's 100/100, okay, that sets the size. So the grid layout will force everything inside the layout to be exactly the same size. This spacing here, the spacing values, control the amount of space between elements. Okay, so as you adjust the amount of space between elements, that changes that part. Now, the padding is space around the outside of the grid layout. So if I go 20, okay, you see how it drops down. But if I add padding to the left and right, okay, it's shifting around, but we can't see it unless we shift the position. So we can go middle left here, middle right. All right, so the grid layout can be repositioned. Middle center. Okay, so let's look at the code that created this thing. All right, so we have several custom objects here. So starting at the bottom, a swatch has a swatch script, and all it has is a sprite. Okay, swatch group has nothing going on visually here, but a lot under the hood. So so this is a swatch. It's just a public sprite. A swatch group starts with a list of swatch objects, and we actually pull those swatch objects out. So here, primary constructor, default constructor, we're initializing the list to empty, and then on awake, we're going to loop through all of the child objects of the swatch group. Okay, and then I pull out the swatch component. So this is either going to be null or not null, depending on whether or not the child object has a swatch. If it's not null, we're going to add it to the list. That's it for what happens with the swatch group. Okay, so the last thing is the swatch panel. swatch panel has three references: a swatch group, a grid layout, and a swatch prefab. So what it does is it looks at each swatch in the swatch group. Okay, it instantiates a new game object with the swatch prefab. Then I set the image, I retrieve the image of the swatch, and I set its sprite to the swatch sprite. Okay, that's it. That's what's happening here. Notice that there's no code. There's no code for the grid layout. The grid layout group does nothing. Okay, what's happening is that on the instantiate line, I am simply assigning the grid layouts transform as the parent of the prefab object, and that automatically puts the elements inside of that prefab. Okay. Okay, I did some renaming here so that we can follow some of these other properties. So I've got swatches now named A, B, C, D, default, and ghost in this same order: A, B, C, D, default, and ghost, so we can see the visual of the grid itself. So here we have the grid start corner upper left, horizontal starting axis, middle center alignment, fixed column count 3. And if we notice, the order of our guys is this is swatch A, B, C, D, default, and ghost. So those are the 6 objects in the grid. Okay, so from upper left and then horizontal, all right, A, B, C, D, default, ghost. If I switch to upper right, A, B, C, D, default, ghost. If I go lower left, A, B, C, D, default, ghost. If I go lower right, A, B, C, D, default, ghost. Okay. I can also change to vertical. I'm going to reset this to upper left though. So here A, B, so vertical first, A, B, C, D, default, ghost. Okay. We can also change the fixed column count to like a fixed row count. Now I've got vertical axis alignment, upper left. So that's going to be A, B, C, D, default, ghost. Or I could switch to a horizontal alignment and it's A, B, C, D, default, ghost. All right. So that's how the grid system kind of associates its objects. Now, one last check here. I'm going to drag the ghost object out so that we have only 5 elements in our grid, just so that you can kind of see how so we're short an element, and then we can see how the different values end up with a missing hole kind of in their placement. So there you go. Okay, for my next trick, I have added an image with no sprite to the grid object itself. So we have our grid layout group, and now we have an image on the grid layout. So if I play this, we can see the grid. Okay, so we have this background image around it. All right, now the purpose of this is so that we can actually watch what happens as we adjust the width and height of the grid. So obviously the grid's cell size is 100, and the spacing is 10. So that means that the total width of this grid is 320 units. So if I reduce the width of the rectangle to less than 320, let's say 250, then we see that it's pulled back behind the grid itself. Works fine here, but if we start messing with the cell alignment, okay, so here we did upper left. Notice how it didn't go to the corner of the panel here. Instead, it went to the corner of its background. If we go upper right, all right, so you see how it's positioning itself in relation to that grid. And if this image were not visible, okay, it would look weird. They're like, why is it lined up this way? Well, it's lined up that way because your size, your image size, is too small. So it's generating some kind of artifacts when we start to work with our alignments. And that could be particularly egregious if we're like too small in both directions. Okay, so here's too small in both directions, right? Any alignment other than, so that's upper center, right? So if I go upper center here, you'd be expecting it to be up here, but it's not. It's clear down here because the size of our background is smaller than the size of our grid. Likewise, so middle center though, middle center will always look okay, all right, because it's focused on the center of the rectangle transform. Okay, so let's keep that in mind. Also, the size of the transform affects the flexible. So before I switch it, let's go up here and change it back to something that fits. So if we fit, instead of fixed column, let's go flexible. All right, so the first thing you should note is that nothing changed. Okay, I made it flexible and it appears just exactly how it was. That's because what it's trying to do is fit the 5 elements inside of a grid inside of its rectangle. So if I adjust the width of this down to, like, say 300, notice that it created a 2-column approach instead of the 3-column approach. So 320 is the number, right, that we need to get that 3-column width, because 100, 100, 100, and 2 tens is 320. If I reduce my height, okay, so that didn't affect anything that way, but if I then increase my width to, say, 1,000, all right, notice what's happened. It created a column, okay? There we go. Or here's a row, right? So see, I can't fit 2 vertically, so what it defaults to try to do is it spits them all out horizontally, right? So you can kind of work with the flexible layout there, adjusting the transform so that you can get the grid that you want to get laid out. And this way you don't have to decide if you want a fixed width or a vertical width. I mean, how much screen space do you have available for any particular device. All right, let's look at an anchor test here for the grid layout. If we just kind of come in here and just start clicking, notice that we aren't changing the position of the grid at all. All right, so we need to get changing the pivot also doesn't help. All right, if we just change the pivot, okay, that's not going to do anything. We need to also change the position. All right, so if we get the position changed down, then we can adjust the position of the grid layout's rectangle inside of the panel. All right, so that can change the position of the grid then inside that panel. All right, if the size of your rectangle is equal to the size of your outer panel, though, then changing your position doesn't actually have any kind of real effect on the position of the grid, because you can't shift the rectangle inside of the panel. All right, so it actually has to be, the width and height have to be smaller than the exterior panel in order to change its position inside of the panel.